Okay, welcome to my video on 7-3 logarithmic functions. So today we're going to introduce a new type of function that will help us solve exponential equations going forward. So here we have a do now where it says find the value of x and explain your answer. So we have 2 to the x is equal to 8. Now, this is a question that we're going to have to use our thinking skills, right? What exponent of 2 gives me 8? Well, hopefully, if I've taught you correctly, that should jump off the page. We know that 2 to the third power is equal to 8. Same thing for the second one. 3 to the x power is equal to 9. Okay? Well, what power of 3 will give us 9? We know that to be 2. So now these are ones that we know off the top of our heads because we know 3 squared is 9 and we know 2 to the third power is 8. But there are going to be many, many questions where it doesn't work out perfectly. So that's the need for a logarithmic function. We're going to use that function to actually help us find what power helps raise us to a particular answer. And now, when I originally did this question, it was a freezing day out. Today is a snow day. So, a nice cold-themed joke for the day. How do you keep warm in a cold room? Go to the corner because it's always 90 degrees. Get it? Right, a 90-degree angle. All right. Hope that keeps you warm on this snowy day. Okay, so let's continue with this idea of what power function. Now, 1 and 2 directly relate to our do now questions, right? We have 2 to the third power is equal to 8. We see a 2, a 3, and an 8 there. 3 to the second power is equal to 9. We see a 3, a 2, and 9. So we know that this particular notation corresponds to the exponential equation 2 to the third power is equal to 8. So what do we see? Well, we see that this little number here is our base. We see that the answer is our exponent. And this time, what was the answer in the exponential now becomes part of the notation, okay? So we see the same thing here, right? The little base, the exponent, and the answer, okay? So now think of this notation. What power? I want you to think of it. What power of 3 gives you 9? That's exactly what we said in the do now. Well, that answer is equal to 2. So if we take that idea and bring it to these bottom 3 questions, right? What power of 6 gives me 36? Well, 6 squared is equal to 36. So the answer to that notation is 2. What power of 2 gives me 32? Well, hopefully you remember 2 to the 5th power gives me 32. And what power of 10 gives me 1,000? Well, 3 zeros tell me that third power. Okay, so again, there's this constant relationship between this notation and the exponential notation. And that's where we're going to be headed for the rest of the lesson, right? What are these connections between these two things? So now what we are saying is what power is actually what we call a logarithm, right? But obviously, we're not going to say what power, but when you see the word logarithm within a question or within a notation, really what you're saying is, well, what power of that little number gives me that answer? Okay, that's what a logarithm is. So, logarithm is a function for finding the exponent of a base given the result. So, log base 2 of 8 is how you would read this one on the left-hand side. What we could read this as is, well, what power of 2 gives me 8? Both of those ideas equal to 3. So you do want to get used to using this vocabulary, right? Log base 2 of 8. But as we can see, it is directly related to an exponential equation. And every single one of these will be related to exponential equations. So a vital skill that we're going to need from this section is converting from one form to the other. Okay? So here we have a few more examples. A question might ask you, put this in logarithmic form, put this in exponential form. So what you need to do is you need to know where the parts go in the opposite format. So remember, the a, which in this case is our base, will always be the same as the base of the log. What goes next to the log? The exponent of the question will always be the answer of the log, because log itself is, well, what power causes this to happen? And then because the exponent switches locations on the side of the equal sign, so will the answer of y, or what we would call the argument. So here we have two more examples. Log base 2 of 32 is equal to 5 because 2 to the 5th is equal to 32. Log base 3 of 81 is equal to 4 because 3 to the 4th power is equal to 81. Okay, so let's make some conversions. So let's write these in logarithmic form. Okay, well, if we're writing it in a logarithmic form, we start with the word log. Well, what is my base? In this case, my base is 7. What is my answer? 49. And the answer to every log question will be its exponents, which is 2. So log base 7 of 49 is equal to 2. Now, those parentheses might change from time to time, okay? The parentheses, if it's variables, might be dropped. But I like to use them, especially when there are numbers. Okay, so the next one. 10 to the negative 2nd power is equal to 1 over 100. Just because there's a negative doesn't change anything. Just because there's a fraction, it doesn't change anything. It's still going to be log base, well, my base in this case is 10, of our answer is equal to our exponent. Okay, so log base 10 of 1 over 100 is equal to negative 2. Okay, now we can work in reverse and write things in exponential form. Okay, so if we're given log base 3 of 81 is equal to 4, we can convert this to 3 to the 4th power is equal to 81. Same thing for the next one, right? Log base 27. So 27 raised to the 1/3 power is going to be equal to 3. Now, any of these 4 examples you can check, right? Now, I didn't tell you how to plug in log into your calculators, okay, but I will. But definitely the powers we can check into our calculators. And so that brings up the question of, how do I type these things into my calculator? Well, I would like for you to look at your calculator, your TI-84, right on the front screen, okay? There should be a button that says log on it. It is right next to the 7, so it says log next to 7. That log button, unfortunately, does not allow you to calculate any logs. It only tells you how to calculate a very specific log called our common log. So a common logarithm is when the logarithm is written without a base. It is assumed that the base is 10. So log base 10 of x is really the same as log of x. We are assuming that the power is that the base is going to be 10. For example, right? We wrote log base 10 of 1 over 100 is equal to negative 2. We could have actually just written log of 1 over 100 is equal to negative 2 because it has a base of 10. Now, if you go to your calculator and you type the log button next to the 7, 1 over 100, you should get negative 2 pop up in your calculator, okay? So that's one type of log that the calculator has on the front part of your screen, okay? Now, there's another button for another type of log with another type of notation. Hopefully, we remember from our last class that a base of e had the same properties of an exponential function when it was raised to a power. Well, we have a corresponding notation for a log for e, which really means log base e, but it has a different, it's written differently. So this is right here, ln. Okay, a logarithm with a base of e can be stated as ln. That ln button is right next to the 4 on your calculator. Now, a lot of students think that is an in, but it's not. It's an ln, standing for natural logs. Okay, so now what does that ln mean? Well, it means that we have a log with a base of e. Okay, so just like we would never write log base 10, we would typically not write log base e unless it helps you to solve a particular question, right? You can do that. But in many questions, they're going to give you ln, and you have to know that it means log base e. And again, any rules that apply to regular logs apply to natural logs as well. Okay, so now, how do you evaluate these on your calculator? How do you get the numbers? Well, we've already talked about log of 100. If I press the log button next to the 7 on my calculator, type in 100, and close my parentheses, I should get 2. ln of 7, right, remember, is also on the front of our calculator. It's the button right underneath the log. So if I press that, ln of 7, and press enter, I get a crazy decimal, 9459. We'll leave it there. So what do these two questions mean? Well, remember, this means that 10, because we don't see it, log base 10, to the second power is equal to 100, which makes sense. Now, for e, a base of e, you're not going to know really off the top of your head what exponent is going to be. But what this calculation did is it found the exponent that should give us 7. Now, if you actually type in e to the 1.9459, you actually see 6.999928957. Okay, now that makes sense because e is an irrational number, you're going to get irrational answers. But as long as it's very close to 7, we know that we have a good answer. Now, the question of the day is, well, how do I plug in this one into my calculator? There is no log base on the front of your calculator. To do this, as long as you have a new updated calculator, is you're going to press the math button that is under alpha, and you are going to scroll down to, on my calculator, it is an A, log base, so it's in capital letters, with a parenthesis. Okay. If you see log with the capital base, you're going to press enter, and it should give you the boxes to fill in. So log base 4 of 32 gives me 2.5. Now, if your calculator doesn't have log base, what you're going to have to use is something called the change of base formula, which is right up here in the corner. Okay. If you do not have that button on your calculator, and you're trying to find a log with a different base, what you can do is you can use the regular log base 10 button on your calculator by filling in this formula. So log base b of a. Well, let's use it for this one. That would be log base b. Oh, so let's do it this way. B is equal to 4, and a is equal to 32. So we could get the same calculation by doing log of 32 over log of 4, using the button on the calculator. Now, when you type it into your calculator, make sure you close the parentheses on the other side of the 32 before pressing division and the log. And you should get the same 2.5. So no matter what calculator you have, you should be able to calculate them. Hopefully you have the log base button, okay, to help you do this. If not, you can use the change of base formula. Okay. So that leaves us with graphing, right? Just like we graphed exponential functions, we also need to be able to graph log functions. And we needed to use this log base feature of our calculator to do so. So to graph it, we do the same thing. We go to y equals. I'm going to press math. I'm going to scroll down to log base, and I'm just going to plug in the values 2, x plus 3, and minus 5. And I look at my graph. Now, from what you see, okay, this graph kind of looks like a square root function, but the thing to remember is that it's not, okay? Logs are directly connected to exponentials, so that means their graphs should look kind of similar. Well, not similar, but should have similar features. So what does that mean? Well, it means that our calculator has an error on it, okay? In the calculator, we only see values starting at -2, -5, 1, 2, 3, 4, 5. -1, -4, 1, 2, 3, 4. 1 and -3, 1, 2, 3. Let's see what comes after that. And 5, -2. So 1, 2, 3, 4, 5. Okay, and what's next? And that's pretty much it. So that's what we get from our calculator. Now, from the calculator, it looks like it stops there. But what we need to do is we actually need to continue this graph going down. Now, why do we have to do that? Well, if we remember exponential functions, they had something called an asymptote. Right? That asymptote was horizontal, and it happened because, right, our graph would kind of cruise along either our x-axis or whatever we're adding or subtracting to it. Well, it turns out that our log function also has an asymptote. Now, you're not going to really be responsible for finding it, but you do need to make sure your graph represents it. So if we take a look, our asymptote is actually going to occur along with this value. Okay, so the x plus 3. So because we have an x plus 3, it's going to turn out that we will have an asymptote at x is equal to -3. And now that does play out in your calculator because the calculator reads, right, an error at -3, which makes sense because you can't get -3 because asymptote means we get close to it, but we never touch it. But it doesn't mean that everything in between -3 and -2 doesn't have a value as well, and it does. So you want to make sure that you include the tail at the end of a log graph to make sure that you're accounting for that asymptote and all the values in between. Okay, so that's important. Now, I obviously did not follow this instruction, so please make sure if you ever get a question like this that you do follow the instructions and make sure you scale it accordingly. Okay. So the last thing we need to talk about is logs and exponentials as inverses of each other. We know that we can rewrite a log as an exponential and rewrite an exponential as a log. So in theory, they are undoing each other, right? Just like subtraction and addition undo each other, and multiplication and division undo each other. So logs and exponentials are going to be inverses of each other. That being said, we can also use these to find our inverse functions. Now, if you remember from the last chapter, inverse function is when we switched the x and y values, right? And then solved for y. Same thing's going to happen here when we're looking for the inverse functions, right? We have our original, and we switch x and y. So this becomes an x, and this becomes a y. Now, what happens here? Well, we need to solve for y, meaning we need to get this y out of our log. And the only way we have to do that as of today is to actually rewrite this as an exponential function. Okay, so how do we rewrite this as an exponential function? Well, we know that this is going to be our base, and we know that this is going to be our exponent, right? And this right here is going to be our answer. So we get y is equal to 3 to the x power as our inverse function. So we didn't actually have to do any solving. We just had to do some rewriting. And that's going to be a key way that we solve these exponential and log equations. We're going to just use rewriting to help us. Now, if you're not convinced that these two things are inverse functions, think about their graphs. Remember, graphs that are inverses of each other are reflections over the line y equals to x. So you actually see, right, a lot of these graphs, part of this graph, are reflections. But what we do miss here is the tail. And that's another reason why we have to have a tail. If this has a tail over here, our log graph also has to have a tail. So that's why we graph it. Okay, so we can use the logs and exponential functions to find inverses of each other, and their graphs should be reflections over the line y equals to x. And those are the homework questions for this section. Part of it is just rewriting. The other half is finding our inverses.